back in the studio, and Jane has some interesting information that may not be real pleasant, but very important. We're going to talk about global warming and something I had not heard of, global dimming. So enlighten us, Jane.
Good morning.
Good morning.
I venture to say very few people have heard of global dimming, but it's an extremely important thing. It is a phenomenon of, without a long history. We don't go back to the BC 2 or 3 millennia or anything for this one, although I may refer to something back there. But it's a most interesting phenomenon. It tends to do what it says. It tends to dim the effect of the solar radiation that comes into the Earth.
Oh, okay.
And what we really hear about all the time is global warming.
Right.
And this, of course, is because too much of it is not radiating off. It is staying in because of bad things in the atmosphere.
Right.
I think we will begin with a picture show.
Okay.
I have 8 nice pictures here that I would like us to look at, and then we can refer back at the end if we have some time for that. So please let us have our first picture. This is not one we're going to discuss scientifically, so fear not. But this shows you the number of phenomena that are going on pretty well at the same time when you're judging the status of the Earth and the atmosphere and what's happening, our environment. You can see the black line up above is what scientists have calculated now is the, as you can see up at the top there, climate change attribution is getting warmer and warmer. Underneath in the light gray is the projection from it. Now, below you see the color things. The blue one going up there is greenhouse gases. Everybody's heard of greenhouse gases. And they have a fairly short history because the phenomenon itself is short.
Right.
But then underneath that, you see various things that can get up there and pollute or not dangerously pollute, either way, the atmosphere. You have the red line where it says solar. This is the amount of radiation we get from the sun. Without that, life on Earth could not exist.
Right.
Then underneath it, you see a couple of other things. You have the blue one, there's the ozone layer, which has been severely impacted. Remember when they stopped producing air conditioners of a certain type,
Right.
in order to, and that's gotten a little better. But then we also see underneath there, the bottom one, or the green one, the big one, is volcanic ash from eruptions.
There's been a lot of that lately.
Well, it just it goes up and down.
Right.
But it's something we have looked at it in some of our past conversations here, the effect it has on world climate and life on Earth. But that is a form of pollution that goes away. The Earth has always been able to clean itself up.
It begins to settle, yeah.
It will, but anything gets up to the stratosphere stays there. But these other things, the other phenomena, don't do that. So if we move to another picture, we will see an aerial view, and you can probably recognize England and Ireland there. And you can see some clouds whirling if you have a little cyclone there. But you also see smudges over the lower part of England, the English Midlands there. And what that represents is the chief industrial area of England. Very industrial, and started being that way already in the 1700s. Another picture will show us this is the northeast corner of China. And once again, you see heavy industrialization. More of China is like that. This area is the worst. But you can see, it shows up. You look back from high above, and you see it just blotted out. And I'm sure we've all heard tales of the terrible condition in Beijing.
Yes, yes.
People wear masks. People get sick. People leave if they can, but of course they can't really leave either. They have tried some. China has made some steps, but not many. Another picture will show us. Another picture, good. This is also China. This is the city of Wuhan. That was what it looked like from above, and this is what much of it looks like from below. And some of our cities are that bad at times. Mexico City also is very bad. Recently they had terrible, they closed the schools even. It got so bad one day. But you can see, peeking down there amongst those skyscrapers, you can see what it's like then to walk around on the ground. Another picture, please. This is another one we all know about and probably don't think a lot about. The vapor trails from airplanes. And we see these all the time now. We see them also from military flights. Anything that goes up there is going to leave a trail that gets up into the upper atmosphere. There's another picture of the vapor trails. Now this one is a little more sinister because you also see clouds, which good clouds are doing their normal function, but polluted clouds, of course, are not. But you see how much stuff is in there now. And when sunlight falls on these things, it is, some of it is glanced off, goes off about a third of it, goes right back into space. But the rest of it either gets down to the ground and is reflected back up and stays there because it can't get out past this, or is absorbed the way it should be into plants and animals, and you and me and all that. Another picture, please. This is rather garish, but this gives you an idea. It is not one single thing that blankets all of the earth at one moment. In different places at different times. Some places worse than others. But you can see Latin America there, and then look up here to North America, and you can see bright spots, bad spots there. Another thing about these vapor trails and the bad clouds, they are white. They're like natural reflectors. The glaciers, particularly the poles, they reflect very strongly, and the rest of things absorb or reflect, and to a lesser degree. One more picture, please. Another picture. This one I love. This is a diagram called about the pans. You see, there's a pan there, and this has to do with evaporation pans. And believe it or not, people keep track of that. That's mentored in many or most scientific installations around the world. And this is the rate at which water evaporates under controlled conditions. And they take account of the composition of the water, of course, and of the ambient temperature and all that. And they come up with conclusions that show them, from which they can derive the strength of the solar radiation, how much of the sun's radiation is getting through to us. And we'll refer back to this presently. Another picture, please. And here's an overall diagram showing there's the sun, here's the earth. The radiation hits us, and of course it's everywhere around us. It's going out. It's not just to us. It's everywhere. But it's being reflected then off of it, about a third of it, and the rest of it, as I say, is coming in. And it's very important, because if we didn't have that, there wouldn't be any global warming to the extent that the way we have it now. But it would revert to earlier times. It would get very, very hot on Earth, and it would be not livable. If it were completely blocked off, of course, there wouldn't be any chance of life on Earth at all. Now, a little history. Before the 1950s, of course, this was not a recognized phenomenon, and global warming was just getting underway then, the publicity for global warming. People were beginning to sort of say, hey, wait a minute, this is greenhouse gases. We've got to do something about this. But they didn't worry about it. They said maybe by the end of the century we'll have to do something about it. Well, the first place for us to look at is Australia. And in Australia, there were a number of these monitoring stations where scientific, it sort of took the vitals, the way in the hospital, they come around, they take your vitals. They took the vitals. Amongst the vitals was the evaporation rate, and they began to notice that it was not exactly consistent. They didn't understand what was happening, but they did understand that it was getting to be less and less.
Less evaporation. Mm-hmm. Okay.
They couldn't quite figure that out. And then when the word came around about global warming, they thought, well, how can this be? Well, then they learned an important scientific fact. It was not the ambient temperature that had anything to do with evaporation. It was the direct touch of the sun's rays. In other words, the sun's rays were having a physical, they were pushing on it to cause the effect. Well, this was an extremely important thing to discover.
Sure.
Well, they wrote up the records and they got into all the annals and everything. Nobody paid a lot of attention to it. But meanwhile, then in Israel, there was an Englishman whose name was Stanhill, and he had spent his life there. He liked the climate and all that. And he was a scientist, and he was working on a project to determine how much irrigation had to be done to make be able to have their crops in desert circumstances. And as he looked around, he discovered also some strange factors that led him to wonder. The solar radiation doesn't seem always to be the same. Well, they looked into the question of whether this was just the sun varying, and they ruled that factor out. So he realized that not as much sunlight, solar radiation, was getting through as had gone through before. So he wrote up his records, and they were duly put in all the annals and so on. He thought, went on. Now, meanwhile, back in Germany, a graduate student named Beata Liefert was down in the Bavarian Alps, not probably just enjoying herself, but she was doing similar studies, solar radiation. And she started to come up with the same figures that these people had. She didn't know it at the time, but she thought, this is some kind of paradox, or what's going on here? So she searched it closely, and she dug up these reports from Israel, from him, and she dug up the reports from Australia, and there may have been some other individual places as well. But this began to be recognized in a small circle then as a definite factor, and they gave it the name global dimming. Because
dimming.
Less radiation
less sun ray was
coming through. And the radiation is vital to life. The ultraviolets, we don't want to take in the ultraviolets into our bodies. So a certain amount of filtering does no harm, but just the right amount was getting through. Now, they looked, of course, at volcanic ash. It got up there and polluted it, and remember we talked about that summer with no summer in 1815. We mentioned when we were talking about the effects of winter, cold winter weather on history. So they dug back and they discovered, something's going on here. What's going on? Well, along in the 50s there, this was kind of the hinge place, the global warming really began to be publicized and recognized as something that was definitely there. Experiments were done in places here and there. There were some scientists investigating the effect of various clouds and the effect of various pollution on clouds, polluted by aerosols and things, and the vapor trails. And we had one of those people recognizing as well, something is sort of cutting back a little on this. But the one in Wisconsin is probably the most important one that I found. He got up one morning. He was an expert on vapor trails, investigating them. He got up one morning, and it was the 11th of September, 2001. And he went to work, and he looked at the sky on the way to work. He was in Madison, Wisconsin, normally a nice climate that time of year. And he thought, gosh, look at all this wonderful, I've never seen the sky so blue. How glorious. And then came the news, of course, of what was happening, and all flights grounded. No flying across the entire United States.
Right.
Imagine that. And it lasted for 3 days, total grounding.
Right.
Came back slowly. And in that short amount of time, there was a not only recognizable, but substantial change in the amount of solar radiation that was coming in to the Earth. Everybody suddenly noticed, all graphs went up. He looked at it, he looked at the figures, and they calculated, and there was a 1 degree centigrade, a difference in the range of temperatures. Now, the range of temperatures every day is very important, too, the lowest and the highest. And that was being seriously damaged, or at least worked on by the global warming. But they, one whole degree centigrade, more solar radiation translated into 1 degree into solar radiation was getting in to the Earth in those days. And they kept taking readings for those 3 days, and they went back the other way once
the planes started
constant
flying. You don't think about vapor trails making that much difference.
You don't. But what they do now, I'm not a scientist, but I looked into this question of what actually happens up there if, say, automobile traffic and industrial waste and things going up there into the air, and your volcanic ash. But what happens, the chemical stuff particularly, sulfur dioxide is the main villain, because what it does, when it gets up there into the clouds, it causes water vapor. And water vapor is sort of a villain too in a way here, because it causes it to coalesce around these little grains. They're tiny, they're microscopic little grains that are up there. And they just rise, the way things rise through water. You rise through the heavier atmosphere to the lighter. Well, they get up there, and that causes rainfall. Now, if these chemicals are doing it, and acid rain is probably a term that everybody has heard at one time or another. And indeed, there it is. Downwind from big industrial areas, or crosswind from it, you notice that. Complaints in the east. Oh, this is blowing in from the pollution in Cleveland, Ohio. It's blowing into Pennsylvania. It's not fair. In Europe, the prevailing western winds were blowing polluted air from the industrial areas in the Ruhr to the east, and from France over the Rhine into Germany. So there's no question that the effect was there. So these the aerosols, the term is they were combined with air, but otherwise you had all this terrific pollution going on. So there was definitely a difference, and something to notice when this was happening. The ordinary clouds can cope with it, but not when they get on. In fact, one of the things that damages is let's see, what's the exact word for that? The water, the hydrographic system, where you have water evaporates and forms clouds, and the clouds rain. Reminds you a little of when you boil water. It boils, and the boiling stuff goes up and it comes down. So just unquestionable effects were happening from it. And people began to get a little more interesting, but still very few people, and really not all that many scientists quite yet were bearing down on it. But you had, I had a figure now between the 1950s and the 1990s, you had drops in Antarctica. The amount of sunlight radiation getting in was 9%. Why? Because the ice, all those glaciers were down there, and sheet ice reflecting it back up, 9%. Some areas in our country registered out at 10%, the British Isles at 16, and probably and again, these are limited areas. It's not the whole globe at once, but limited areas all putting in their 2 cents worth to it. In Russia, 30%.
Oh my goodness.
Yeah. So definitely you had this going on. Clouds over the Maldive Islands, in the Indian Ocean. An important step forward was made in recognizing this, I think principally through an India scientist whose name was Ramanathan. In the northern part of those islands, they were getting all the downwind from the pollution in southern India, industrial pollution. The southern part of the islands, they were getting primarily air input from Antarctica, which was much cleaner, of course, than southern India. So they got going and they really did some testing on that. And that's where they discovered these, what you'd think would be little tiny factors. Well, they are tiny factors, but when they build up, they produce these horrendous effects.
Yeah, we don't think about just the things we do every day and what we're putting into the air.
We don't. I think we did maybe for a little while about the air conditioning, when people were saying, I want to buy an air conditioner that's whatever they did to them to get rid of that. I think we're stopping using certain chemicals and replacing them with others.
But we're not interested in giving up our cars and all these things either. You wanted to have the last 5 minutes, so we're there.
Yes, now I want to conclude by reading. There's a lot more to be said, and you'd find a lot more online if you want to pursue this, but it's a shame that nobody's even heard of it. The good news, you can conclude from some of this, is that global dimming seems to be reversing itself since 1990 because we're cleaning up the environment. We really are, in places on the Earth, but not everywhere. Meanwhile, of course, the glaciers and the poles are still melting at high rates. Now, the bad news, on the other hand, is that the increase in dimming may be leading to an underestimate of global warming. Underestimating the effect global warming is having because this is mitigating it. And then also, they can occur at the same time, but that won't do us any good either. So you have to think about some of these factors. Now, a man named Jasper Kirby, who was a particle physicist, wrote, we know that global warming and global dimming are indeed happening and faster than expected. And we have many proposals for solution. But, he writes, and sadly, this does not mean we are using what we know.
Yeah.
And this is a constant reminder that we are living in a time when genuine science and errors, when genuine science and scientists are routinely marginalized. Don't worry about it. And undermined by prevalent thinking errors, confusion, fake news, and denial campaigns. Oh, scientists will always think, don't worry about it. Scientists will think of something. But that's not going to happen anymore.
Yeah,
the oceans are full, the air is full.
Well, and when you mention the fact of all these particles causing more rain, look at what's happening right now.
And it's bad rain.
With all of this horrible rain that we've had,
yeah.
There's just flooding
and
where there's never been floods before.
Then when the storm comes, there's more water to throw around.
Right.
Now, people are not likely to do this, to get with it, but there's a need for aggressive action. One historian wrote, but geoengineering must be drawn out. There's a new historical term for you, geoengineering, which means using the Earth itself as a tool. And they did some research, trees release molecules that contribute to cloud seeding, which the clouds need to be seeded to rain.
Sure.
But not with sulfur dioxide. Studies are showing that aerosols can form and grow to the size needed to seed a cloud from molecules naturally emitted by trees without requiring sulfuric acid. Now, if this isn't a real plug for reforestation, but as long ago as Plato, in 2 or 3 millennia BC in Mesopotamia, they knew they were forbidden to cut down trees after a certain point. But they knew then, Plato warned specifically, our whole environment is going to change if you take away all the trees.
That's right.
Dirt will wash away. They knew it that far back. Now, there's a new book, I think it's a new book, The Extinction Crisis. It is frightening but true. Our planet is now in the midst of its number 6, of its 6th mass extinction of plants and animals. Big in the news just recently about some extinctions, but I wasn't aware that that was the number 6 time that had happened. But he goes on here. The last time this happened was 65 million years ago when the dinosaurs
For heaven's sake.
were made extinct. Although extinction is a natural phenomenon, it occurs at a natural background rate. And the background rate is about 1 to 5 a year. But scientists estimate that we're now losing them at 1 to 10,000 times that rate.
Oh dear.
And this recent one, what was several thousand?
Yeah.
Yeah, so just in that little bit of time. And the final thing, well, it could be a scary future indeed, with as many as 30 to 50% of all species possibly heading toward extinction by mid-centuries. Things that keep the cycle going, things that provide our food, grains. And the very final thing is a quotation from Kennedy, from JFK, that Kennedy. And he said, oh, help, where is that? Yeah, he said, whatever way you look at it, we live on a dying planet. And that's true, eventually the sun will expand. But dying does not mean actually dead. Despite all damage that people have done to planet Earth in the last 100 or so years, and he's writing in the 1960s, the Earth can repair itself if we do the right things.
If we're willing to give up some of our luxuries and, yeah.
And people in charge are willing to take
Right.
it and lead us, to
Okay.
good things.